Hi all, I am Tejeshwar. I am working as a junior data analyst trainee intern as in Data, and this is my next task, civil service result analysis. I am going to do this in Python file or Python it's in root. Okay, so I am going to use in this Python language. Okay, so in this case, first we want to import the necessary packages. So first import the NumPy is for any algebraic calculation or any mathematical uses, and pandas is for data processing, and matplotlib and seaborn is for your visualization power. Sorry, I think there is okay, and matplotlib and seaborn is for your visualizations and warnings. If there is any warnings or any unnecessary things arrives, just this warnings, ignore those things. So we can just run this cells. Okay, so next I just want to import my dataset. To import my dataset, I want to use this PD read CSV function, which is in this PD, which is known as pandas. Okay, and I'm going to save this in this data as a variable, and this is my path. I'm just uploaded my file here. Just clean this three dots and just clean this copy path so that you can take the path and paste it here. And after just after loading your file in this data variable, you want to see what is in our data. So just run this thing. I will get the data set here. So you can see like whatever it is, like exam number, which is like roll numbers, and list number, which is for list title. Like you can see here what are the lists here, and the first name of the who's that, the appeared exam person, and middle name, last name, and the total marks they pursue, and list title code, list title description, for what list they have applied, and the group number, agency code, list agency description. These are all the things here. So we have totally around 491,644 rows and 20 columns here. Okay, so this is our data set, basic details of our data set. And next we are going to see the basic info. So to see the basic info, just use this info function, which is an inbuilt function here in Python. So this info function just gives you like what are the column names and the non-null count, which means how many proper values there in that each column. So let's take our, for exam number column, there are around 491,644 non-null values, which are proper values are there, which is in the int data type format. For list number, it is in float data type. For like all, so for all these things it has. Okay, so in this case you can see this list div code is not having any values, which is zero non-null, which means everything is there is in null values. So we can't able to use that column. Like this we can able to see here. And total memory usage, our data set is using a maximum of around 75 MB memory for loading and pre-processing the data. And next, the describe function. The describe function is just used only for integer type or numerical data types attributes. So in this case we have only float and integer. So there are around 7 columns is having in the numerical data, right? So we can see here these are the 7 columns. Okay, for the 7 columns we have this describe function, which gives our total count and the mean of the total thing, and the standard deviation, minimum value 25% and 50, 75 maximum. These are the things we have. Okay, so we want to see the data types. We already saw here itself, it is in this here. But if you want to see separately only a data types, just use this d types. It is also an inbuilt function in this Python. So these are the exam number is an integer data type, list is float, and you can also see all those things in this format. Okay, so at last our total file is in this object data type, because we have maximum of object data type, so it comes under the object data type. and to check if there is any null values present. So to check whether there is any null values, just we want to use this isNull function. To add all the null values, I'm just using this sum function. So in this case, we are getting these things. Exam number and list number doesn't have any null values. First name has around 7 null values, and middle name it has around 221, right? Or no, 291,000 something. Sorry, 19,000 something. And it all has a lot of things. We already saw it that listed code doesn't have any values, which means total values are null values that is represented here, and these are the null values we have as much as possible. Okay, so these are the basic details. Okay, and now we are going to use this visualization part. As our title represents the civil service result analysis, we want to use the visualization method to get the more analytics in this. So at first, I'm just going to set my figure size. In this case, if it is an optional thing, it is not an exact point to what you want to do. If you don't put this, it arrives the output, but not in the specific shape. If you want any specific shape, just use in this case. Okay. So at next, the SNS. I am just going to use this SNS, which means Seaborn, right? So I am just going to use the Seaborn to plot the histogram plot for the data's adjacent FA. This FA is the total marks that can be get by the examiners, not any students. Okay, and bin is equal to 30. We will see here. Okay, this each boxes represents a bin. So there is around total 30 bins from this left corner to the right corner. Okay, and KD equal to true means just represent this line plot. It's not a line plot. It is the KDE in this histogram. And the color equal to sky blue, which is this color. And I'm just going to put this title as a distribution of exam scores by using this plt.title function. And to place the X label exam as an exam score, I'm just going to use this X label. And for Y label, I'm just going to use this Y label. And after this, I'm just going to use this show to show the function. So I'm just running this output. So it takes some time. Okay, so we are just got this output. In this case, you can say this total 100 is the more frequent what is adjacent FA, right? Adjacent FA total score, and the next most highest is 90 point something. So it may be 90.2, around 90.2, 90.4, 90.6, 90.8, and it may be 100. So it will be in this function, and this is the first thing, and this is the second thing. So this is the distribution of exam scores for students. Okay, so that's it. We can go to the next thing, and I'm just going to calculate the names. Sorry, it's not an calculation. I'm just going to retrieve the names of the top 10 candidates. Okay, in this case, I'm just going to take their last name, which means our name has two names, right? First name, last name, middle name. In this case, I'm just going to use this last name to calculate to retrieve their last names of the top 10 candidates. Okay, so I'm just going to take this data last name as an attribute, and I'm just going to count all the values using this value count function. And in this case, I want the top 10, so I'm just using this n largest. It is also an inbuilt function to take the n number of largest things from the attributes. So in this case, I'm just going to use this 10, which means the top 10. Okay, and now I'm just going to use this plt.figure to plot my visualization in the particular size. And I'm just going to top last names, which I've just retrieved this top 10 last names and the top last name variable, and I'm just going to plot this in the kind of bar plot. And color equal to salmon, which is this like a pink color. And I'm just going to use this plt.title to place the title names, and X label for the label which is having here, and Y label is for frequency, X-Ticks. This X-Ticks is just for this Williams Rodriguez. It is in the slanting way, right? So this 45 rotation is known as, this is in 45 degree. So the 45 degree is known as like a slanting way. So it is in the slanting position. And I'm just using this show. So I'm just running this output. Okay. So the Williams as a last name is taking more, is having the more last name power, which means there is more Williams in the civil service examination. That's it. Okay. So the next more is Rodriguez, next is Smith, and next is Brown. These are the top last name or appearing for the examinations. This is the insight you can take from this. And as same as we can go to the next thing for established date. I am just going to plot the exam establishment over time, like established date and the year. Okay, so established date and the year. In this case, we have an established date as a column, but it has an object data type, right? We already saw here itself. The established date is in the object data type. So we want to convert it to in the data frame, like date time format. So I'm just going to use this to date time. It is an inbuilt function in the pandas package. So I'm just going to use this pd dot to date time, which is an inbuilt function to change the date time into the date, month, and the year. So it just what we can say, it just separate all those columns, all those values into date, month, and time, and save it in this data established date. So now this established date column has three things, which is date, month, and year. So in this case, I want only years for plotting this plot. So I want to take the year from this established date column, right? So I'm just going to create an create an data frame, which is established year, and I'm just going to extract the year from this established date column, which means, let's say it is like 2004. Okay, in this case the 2004 is only I need, so it is in the year. So I just want to take the particular year only. So I'm just going to use this date column here, and I'm just going to retrieve this dt.year, which means a particular year from this column. So I'm just going to retrieve this year, and I want to take the total frequency, right? So to take the frequency, I want the counts. So for that, I'm using this value counts function. It is not in the sorted order, so we can't able to see it is in this only in this sorted order. So I want to sort those things, so that I'm just using this sort index function. So what it comes so clearly and neatly. Okay, as same as I'm just going to plot these things, and I'm just going to use this line plot. It's a kind of line plot, and marker equal to 0, which means you can able to see here itself, right? The dot, that's thing, and the color equal to orange. I'm just going to use this orange color, and plt dot title, which is for this title, and plt dot x label for this labels, and plt dot y label for this number of establishments, and plt dot grid equal to 2. In the line plot, it is possible to plot this plt dot grid. So you can able to show this grids, not in the line plot, even though you can use for any plots, and plt dot show to show this output. I'm just running this. Okay, so you can able to see how it is trending. Okay, from 2015 it is increasing gradually, and after 2017 you can see here it is increased rapidly up to 2021, not 2019, sorry, it is increased rapidly up to 2019, and the 2020 it totally demolished, which means totally decreased, and after 2020 it gradually increased in 2021 and 2022, and again at 2023 and 2024 it is falling around. So it is like how the exams has been gradually increasing and decreasing over the particular period of the year. Okay, so this is the thing we can be able to get from here. And then next, pass rate by agency. The agency in the represents like an institution for the coaching of the students, like those things. Okay, so this is the thing, list agency description, right? These are the agency, or sorry, these are the agency which takes the students for the training, or it takes like for what they are going to what we can say, what they are going for the position. Okay, so I'm just going to compare this list agency description and the marks scored by the particular student. Okay, so I'm just going to group those things by using this group by function. Like for each list, which means for each agency, I'm just going to add these things. Sorry, not an add, it is an mean. Okay, so I'm just going to take the mean of the adjacent FA, which means the total percentage taken by the students for all those separate particular agencies. I'm just going to take this mean and I'm just going to sort those things, and after that I'm just going to plot. That's it. Okay, so you can able to understand using this plot. First we can see the code. This is the plt.figure for the particular size and pass rate agency which we got above. I'm just going to plot in the kind of bar plot, and by using this color equal to orange. And as same as all, I'm just going to use this title function to place the title, and x label to place a label underground, right? Okay, label, and y label as an agency here. Okay, so now after running this, okay, so in this case, this the topmost is district attorney special narcotics. It is the highest attribute or highest agency for the pass rates. So if you take this district attorney something, right, district attorney special narcotics, you can able to be passed a more number of it has more number of possibility to pass in this agency by using this agency. Okay, these are the things you can see. These are the things like this is in the from right to left, it is going on from passing to more marks to less marks. Okay, so this is the thing you have. And next, so now I'm just going to take the total duration. Okay, how much duration from the published date and the established date. To take those things, as we already changed this thing, like established date we already changed it here, but I'm just doing because of this. Okay, it's not at all needed. You can also use this. You don't want to use this too. Okay, and as same as for established date, I want to do for published date, like date, month, year, I want to split. So I'm just running this cell. Okay, so after this, I want to calculate the total number of days between the published date and the established date for that particular job or particular student or particular list. Okay, anything. So I'm just going to calculate the total duration in respective of days. So I'm just minusing, or I'm just going to subtract the established date from the published date. So I'm just going to use this days function, days as an value. So in this case, I'm just using days as a value, which represents like, I'm not taking like for about we takes an year, right? So in this case, I'm just going to take the days, which for each month it has a dates like. So I'm just going to calculate with the respective of dates. So this is the total, what is this size? Okay, particular size of this data, plot. And I'm just going to use this histogram, and this is the data. So I'm just going to use this data. If there is any null values, I'm just going to drop, because there is any null values present, it is a possible to we have. So I'm just going to drop those things, and I'm using bins equal to 30 and color equal to sky blue, edge color is in black. So we see what are the things it has. bins equal to 30, as we already seen, these all squares, or it's not a square, these all rectangles all represent as an all rectangles are represents as a bin, and colors, this are the colors is sky blue, and edge color you can able to see here, this edge color is in black. You can also use any other edge color, and I'm just going to use this title, X label and Y label for this label things. Okay, so yeah, I think I didn't run this side. Okay, so this is the thing, and in this case you can see around 300 days it is the maximum duration. So most frequent duration is 300 days. Okay, so they publish the date and they establish date between maximum, sorry, it's not maximum, average or most frequently we will get by 300 days. It is in duration of that particular exam. So it is the next thing. Okay, so I think you can understand from these things. Okay, so I'm just going to use the next, which is for scatter plot. Okay, as already we seen, I'm just going to use this plot for the particular size and SNS. By using SNS, it is an Seaborn function. I'm just going to plot this scatter plot for X duration, which we already calculated here, and Y equal to adjacent, which means we are just going to calculate by the duration time how much the percentage or the total, what we can see, the marks, is there is any relationship between the duration and the marks. Okay, so I'm just going to use the scatter plot to plot this X and Y. Data is our data, so I'm just going to use this plt.title for this title, and X label and Y label for this label functions. And we just a minute, it takes some time. Okay, as we already see, the 300 is the most frequent thing. Here also the 300, it is the most frequent thing. So for the 300 days, it is the marks, which means the exam score, it is more above compared to others. Okay, so maximum it is around like from 100, oh no, yeah, from 100 to 200, sorry, 100 to 400, the maximum marks will be arrived, which means if there is particular 100 to 400 days difference, the marks will be more, which means the preparation time is more. Okay, so yeah, that's simple. And this is the plt.figure. I'm just going to model the size. So in this case, I'm just going to put the heat map. Heat map in the sense it is a correlation plot. Sorry, it is also known as correlation plot. We are just going to calculate the correlation of that particular values. So the correlation will be calculated only for the numerical attributes or numerical columns, anything you can see. So I'm just going to take the numerical columns. These are the numerical columns I have in the particular data set. Okay, so I'm just going to take all the numerical values, and I used core, which is an inbuilt function to calculate the correlation. And for this core, after calculating the correlation, I'm just going to save this in the correlation matrix, and I'm just going to use it is in the heat map function to get the correlation. So by using this value matrix here and annotation, which means represents this values, so like you can see here the values, it is annotation, and CMap, which is the color map, and line width equal to 0.5, which is this line width. So you can see this white line, this is the line width. And title, I'm just going to place a title here, and plt.show, which represents to show. Okay, so what you can able to get from this, so you can able to get what are the things are more related and not related. Okay, so to get the more related things, you can able to see this dark blue colors. So from here, from dark blue the dark red, the dark blue represents the not correlated, the dark red represents the highly correlated. Okay, so in this case the light blue is this highly correlated, or we can say it is the mediumly related things, because the red is more correlated. The red won't arrive until it reaches the same attributes. Okay, so leave this diagonal. You can also see only this triangle or this triangle, both are same. Okay, so let's take list of title code. So the most related things are 0.28, 0.28, which is list number and list title code. So the list number and list title code are more related, and second thing, exam number and the list title code are more correlated. Okay, these are the things we can able to get from this heat map. And as same as you can also get the more unrelated, which means most not related things. It's not unrelated, it's not related things, like plus minus 0.11 as minus 0.12. So minus 0.12 is the most, I think so. Okay, so list number and list agency code is the most unrelated things in this data set. Okay, these are the things we can able to see here, and I think this is the last. Okay, so this is the violin plot. Violin plot is majorly shows you like a box plot. It is in the, it's not a, it's like it provides the same things from the box plot, but not in the box format. It is in the wave format. Okay, so I'm just going to use this violin plot function. X attribute as a veteran credit and Y attribute as a marks, total marks scored by the particular students, and the hue represents the colors. Okay, so how the color wants to be differ from those things. So that's the thing here. And data equal to data, which is our data, and I'm just going to split those things because I don't want two things as a same. And inner equal to quart, which is the quartile things, median, first quartile and third quartile, and palette equal to pastel, which is the normal colors. And plt dot title, I'm just going to place a title violin plot of adjacent FAE. Okay, so you can able to see here, and this is the plot. Okay, so I'm just going to run this. Yeah, the plot has been added. So in this case, you can able to see the disabled veteran credit. For these things, around 115 is the median value, and around 108 is the, around 108 is the first quartile, and around 118 is the third quartile. For veteran credit, around 105 is the median value, and around 95 is the minimum value, and above 115 is the third quartile. So these are the things we can able to get from the violin plot. Okay, yeah, that's the thing. Okay, so that I think you can understand. Yeah, okay, thank you.